We're now going to look at graphing quadratics in vertex form. What you may not have known is that y equals a x minus h squared plus k is called vertex form. Because recall that h and k gives us the vertex. So using this form, we now know three things. We know that the a value will cause the graph of y equals x squared to be stretched or compressed. So stretch or compress y equals x squared by a factor of a. And remember, to be compressed, the a value will have to be greater than 0, less than 1. And to be stretched, the a value will have to be negative. The second thing it does, it tells you if the parabola opens up or down. So this tells you if there's a reflection across the x-axis. Only if a is negative or less than 0. So a gives us a lot of information. It tells us if it's stretched or compressed. So remember, stretched, a is greater than 1. Compressed, a is between 0 and 1. And a reflection if a is negative. We also have the h value, which we call a translation of y equals x squared, left or right, by h units. And finally, we have k, which is a translation up or down. By k units. So with that information, we're going to be able to graph y equals a x minus h squared plus k by starting with y equals x squared and applying the transformations in the following order. We are always going to start with the vertical stretch or compression by a factor of a reflection across the x-axis if a is negative, and sometimes we can combine these two. And then finally, a translation left or right h units and a translation up or down k units. So that's what we're going to practice with the next few examples. Transforming the graph y equals x squared into the quadratics given in the examples. So we're going to start with the first one, y equals 2 x minus 4 squared plus 3. So we are always going to start with the base graph y equals x squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So do the same thing on the other side to get our parabola. And there is the graph y equals x squared. And again, if you don't know how I got those values, let's just do that up here. We have x, we have y equals x squared. So let's say we started with negative 2. Negative 2 squared equals 4. Negative 1. Negative 1 squared equals 1. 0 squared equals 0, and so on. So that's the first one. The next one we need to do is deal with the a. Since the a value is 2, that means we're going to stretch y equals x squared. So we're going to multiply all the y values of this graph by 2. So starting with this point here, let's say, that's y equals 1. I'm going to keep the x value the same and multiply it by 2, so that gives me 2. Going to the next point, y equals 4 in that point. If I double that, I get 8. And then do the same thing on this side, multiply the y values by 2. And 0 times 2 is 0. So this is what we call the stretched graph of y equals x squared. I multiplied all the y values by 2. So the red graph is y equals 2x squared. Let's make this a little bit neater. The black graph is y equals x squared. The red graph is y equals 2x squared. Let's go to the next one. Now we have to deal with the 4 and the 3. So remember that 4 That tells us h is 4, not negative 4. So that's 4 to the right and 3 up. So we're going to take the red graph. So we're going to take each point from the red graph, move it 4 to the right and 3 up. So 1, 2, 3, 4, 1, 2, 3. There's the first point on that red graph, the vertex. Next one, 1, 2, 3, 4, 1, 2, 3. And then we keep on doing that. I don't think I can get the next one. No, it's too high. So there is the final graph. That is y equals 2, because we already did the 2, x minus 4 squared plus 3. So on your graphs, I expect to see a legend identifying which graph is which. So now let's do part 2. I'm saying compared to y equals x squared, y equals 2, x minus 4 squared plus 3 is what? And we just write it out in words. We say, and we start with order. So we start with the a value is stretched by a factor of 2. That's the first thing. And then we can say translated 4 units right and 3 units up. And that's all you have to do to describe the transformations. So the black graph is stretched by a factor of 2, and then the red graph is translated 4 units to the right and 3 units up to get the green graph. All right, let's try a couple more. So again, start with the base graph, y equals x squared. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And then the matching points on the other side. So there is y equals x squared. Let's put that over here. Y equals x squared. Let's take a different color. Next, we have to deal with the a value. So in this case, the a value is negative 1/2. So we start with that. That means we're going to compress by a half and reflect. So you can do this all in one go if you like. I'm going to take the y value of 1, so starting here. It's going to be half its original height, but then it's going to become negative. So it's going to go down here. The 0 stays as 0. And then go to the next point, which is at 4. So half of 4 is 2. And then take the negative of it, so it becomes negative 2. Notice I'm not changing the x values, just the y values when I apply the a. And then the last point up here is 9. So the negative of 9 is negative 9, and then half of that is negative 4.5. So there are the final points here and here. So I compressed by a factor of a half and reflected across the x-axis. The last graph should be y equals, we already did the negative 1/2, but we still have to do the x plus 4 squared minus 3. So remember the plus 4 is actually negative 4, so I'm going to go 4 to the left and 3 down. So 1, 2, 3, 4, 1, 2, 3. There's the vertex. Then graph the other points by counting over as well. So there is the final graph. So I took the black graph, I took all the y values, divided them by 2, and then made them all negative. That's how I got the red graph. Then I take the red graph and move it 4 to the left and 3 down. So let's write that out in words. So compared to y equals x squared, this graph is compressed by a factor of 1/2 and reflected across the x-axis. That's the first thing that happened. That's how we got the red graph. And then secondly, it is translated 4 units left and 3 units down. And there is the description of what we've done. So you need to be able to do both. Graph them and describe what the transformations are. And don't forget your legend. This one, you notice we're missing the x minus the h. So in this case, this is telling us that h is equal to 0. Because remember, our base equation is y equals a x minus h squared plus k. If I take out the h, that leaves me with ax squared, which is what we have here. So starting with our base graph, y equals x squared. So again, just squaring the values as I go through. So there's y equals x squared. So add that to my legend, y equals x squared. Next graph, I start with the a value. So y equals negative 2x squared. So I'm going to stretch all the y values by 2 and make them negative. So the first one was at 1. So times it by negative 2, that gives me negative 2. And do the same thing for the other point. The next one's at 4, so it becomes negative 8. And I can't draw the third point, so I stop there. And finally, I don't have an h, so I'm not going to move this left or right, but I am going to shift this upwards by 5. So I'm going to add 5 to the negative 2x squared, so the red graph goes up 5. 1, 2, 3, 4, 5. And there's the next point, and then 1, 2, 3, 4, 5. And there's the final point. And if we sketch that graph, there is our final graph in green. So let's describe this in words. So compared to y equals x squared, y equals negative 2x squared plus 5 is stretched by a factor of 2 and reflected across the x-axis, and then translated 5 units down. Translated 5 units down. So there's the description of our transformations. So last part, compare the h and k values with the vertex for each example above. First one was 4 and 3, and then we had negative 4 and 3. So the first one was 4 and 3. The second one was negative 4 and negative 3. And the last one was 0 and 5. And what you should have noticed is that the vertex was 4 and 3. The vertex was negative 4 and negative 3 for the second one. And the vertex was 0 and 5 for the final one. So the translations determine your vertex.